Hey everybody, this is Dr. A here, and in this video we are going to be providing some background information as well as some introductory information on mechanics of materials. So what is mechanics of materials? Well, as we've already written down here, this is a branch of mechanics that studies the internal effects of stress and strain in a solid body that is subject to external loading. Okay, so when we say it's a branch of mechanics, it's in the same family of material as other subjects like statics and dynamics. Those are also branches of mechanics. Statics is a branch of mechanics that studies forces and their effects on bodies. Dynamics is a branch of mechanics that studies the forces on systems that cause them to move, that cause motion. Whereas mechanics of materials studies, again, the effects of stress and strain in bodies that are subject to loading. So let's dive a little deeper into this. What is stress first? What is the basic idea of stress? Well, stress is associated with the strength of the material of which the body is made. And then we have strain. Strain is a measure of deformation of the body when it is loaded. So this is the very basic idea of stress and strain. I'm going to underline the word deformation because that's an important word we need to kind of store in the back of our minds, okay? So when we talk about bodies being loaded, what do we mean by that? Well, you may remember the idea of this from a course in statics. So external loads, which can be forces and moments applied to the body, may be considered as either surface loads or what we call body loads. Okay? A surface load is developed by the direct contact of one body with the surface of another. A body load is developed when one body exerts an action on another body without direct physical contact. So an example of this is self-weight. An example of a body load is self-weight, or the weight of the body itself, the weight of the actual body that you are looking at or analyzing. Okay, so we've said a couple of key words here a minute or so ago. We said forces and moments. I didn't mean to put the highlighter on. Forces and moments. Okay, now from your knowledge of statics, you should remember what forces are and what moments are. But in case you're a little rusty on that, we're going to give a quick definition of those. Okay, so forces are represented by vectors which have a magnitude and direction. They have English units of things like pounds, kips, and tons. Now, if you remember, 1 kip is equal to 1,000 pounds, and 1 ton is equal to 2,000 pounds, or 2 kips. Okay? In SI units, the base unit of force is newtons. So we abbreviate that as N. And so, of course, we have all of the SI prefixes that you should be familiar with. For example, 1 kilonewton is 1,000 newtons, 1 meganewton is 1 million newtons, so on and so forth. Okay, so those are forces. Now, what about moments? What about moments? Moments are also vectors that cause what's called a tendency of rotation of a system or a component of a system. A moment caused by a force is computed by multiplying the magnitude of the force by a perpendicular distance. Okay, and that's for 2D problems or 2D systems. So what would that mean? In English units, a moment would have units of something like pound feet. That's the units of pounds times the units of feet. Or what about maybe kip feet? Or maybe pound inches, okay? So again, the units of moment have units of force multiplied by a distance, and specifically, it's a perpendicular distance when you're dealing with 2D systems. In SI units, moments would have units of, for example, Newton meters. So that's newtons times meters. Or again, you can use the same SI prefix as kilonewton meters. That's kilonewtons times meters, okay? Some other important aspects of statics and physics that we need to remember when we're tackling problems in mechanics of materials. The next important aspect that we need to remember is what we call external support reactions. So what are those things? Well, external support reactions, we're going to underline that because that's really important, develop at points where a system is supported, or at points of contact between bodies. Okay? So let's look at a table that has some common two-dimensional external support reaction figures. Okay, so I'm going to switch screens here, and we're going to take a look at this, at this table right here. As you can see, I'm having trouble scrolling. Okay, so this table is called Common Connection Types with Idealized Model. So in this table, we have several different connection types. If we look at the leftmost column, the second column is entitled Idealized Model. That's like what the symbol or the way we draw a figure that's related to the connection type. The third column is the reaction that's developed. And then the fourth column is a quick description of the number of unknowns. So for example, that first option there, the first connection type is called weightless cables and links. And so if you look at the ideal model, we have a nice little, almost like a stick figure with the weightless cable or link at some angle theta from the horizontal. The reaction that develops is going to be one unknown force along the longitudinal axis of the cable or link. Okay, now let's look at the second one. The second connection type should be pretty familiar to you from maybe statics or even physics. That's a roller. A roller is idealized as a little circle or ball on a surface, resting on some kind of surface. In this idealized model figure, we have this roller that's resting on a horizontal surface. And the type of reaction it develops is one unknown force reaction that is normal, which means perpendicular to the surface at that point of contact. That's why that reaction force F is pointing straight up vertically. Rockers are very similar to rollers, so I'm going to skip down a little bit. The next type we have is a smooth contact surface. A smooth contact surface is also similar to a rocker and a roller. It develops one unknown force normal to the surface point of contact. Again, notice that is in a vertical direction, okay? And we also have several other options here. So my suggestion to you, the fixed support is the last one at the end. My suggestion to you is maybe pause the video, go back, rewatch some of this as I'm scrolling through this table so you get comfortable with what these all are. We also have smooth pinned collars. We have smooth pins. A smooth pin is a very common reaction type that you see a lot in a statics course. It has two unknown force reactions. We have fixed collars, which has two unknowns. One is an unknown force, one is an unknown moment reaction. We have a fixed slider, which again has two unknowns, one unknown force reaction and one unknown moment reaction. And then at the very end of the table, we have a fixed support, which has three unknowns. Two of them are forces and one of them is an unknown moment reaction. So what these reactions are they are either forces or moments that develop wherever motion is restrained. Wherever motion is inhibited or not allowed to occur, a reaction will occur, okay? So let's go back to our description here, okay? These support reactions develop where a system is supported, okay? So they develop where motion is restrained or prevented. Okay? Now, for 2D, or what we sometimes call planar systems, each support may have either 1, 2, or 3 reactions develop. So if you go back and maybe if you rewind the video and you look at that table that we just went through, if you notice each one of those external support reaction types either has 1, 2, or 3 reactions that developed. None of them have 4 reactions, for example. If it's a 2-dimensional planar system, then each reaction would develop or each support would develop either 1, 2, or 3 reactions, okay? So another little refresher, important point from statics and physics, is when you begin solving problems in mechanics of materials, you always want to draw a free body diagram of the system, okay? So let's write this down. We're going to say always draw a free body diagram. We sometimes abbreviate that FBD of the system to be solved. Now, what is a free body diagram? Well, if you remember, this is a simple diagram of the system that you're dealing with, showing all known and unknown forces and moments, along with any dimension lines and angle measurements. Okay? Now, once you draw a free body diagram of whatever system you're interested in, you typically then apply equilibrium equations to solve for unknown forces and moments. Okay, so we'll make a note here. Then we can apply equilibrium equations to solve for unknown forces and moments in our system, which unknown forces and moments are oftentimes those external support reactions we just talked about. So again, this concludes this video. This is really just meant to give you both an introduction to the idea of mechanics of materials while also reviewing some important topics that you should bring with you from your statics and physics classes. Please go back, rewind, watch parts of this video as you need. Please hit like and subscribe if you found this helpful, and we'll see you in the upcoming future videos. Thanks for watching.